Can I share my screen? Do I have
Yes, you
permission?
are the co-host, yeah.
Okay, thank you. All right, so, okay, so we've started implementing, and as we implement, some new questions have come up. Before I jump into that, I want to quickly recap what we've been doing so far. So, as of about 2 weeks ago, we agreed upon the overall design of the system, and we've updated the KEP to have the latest designs that we've all agreed on, and I think some of us, some of you have already reviewed the KEP. I humbly request that you take some time, those of you who haven't had a chance to review yet, take some time to review the document and leave your feedback. And as of last week or so, we started discussing about the implementation of the project. Since we have an overall understanding of the design, we could move forward with this. Now, in terms of implementation, as we start writing code, we ran into a few decision points that we're still that still need some clarification. So that's what I want to bring up today. So, starting with the API group. I wanted to quickly review what the API group for CSI volumes look like right now. So in case of CSI volumes, the API group is or CSI specific objects. The API group is storage.ktos.io. This group does not have any implementation specific details in the group name itself, like it doesn't say csi.ktos.io. And it's pretty neutral in terms of what it does. It's just storage rather than some specific type of or specific implementation of it, like CSI or Flex or any of the other things we've built before. So what we came up with initially for Cozy was cozy.sigs.ktos.io. Now, this to me sounded like it is not quite well aligned with what we've been following so far. Ideally, when we create a group like this, a new group like this, it sounds like we're almost creating a new standard, and it's different from CSI. It's like it's competing with CSI almost. Ideally, though, we want to be aligned and not compete with it. In the sense, the question of Cozy being something entirely, or in the best way for me to put it is, the way I see it is, object storage is another form of storage, really. I don't know if it should be a separate standard that users of Kubernetes will have to compare and contrast against CSI with. So I'm thinking, I'm just open to suggestions too. Cozy should ideally, in the long run, go into storage.ktos.io, that API group. And I can imagine this being a bottleneck for us to move forward with getting the API in. However, if the process of getting the API in is going to be a huge bottleneck, there is another option, which is for now, in the short run, while we're waiting for the API approval to happen, we could use objectstorage.ktos.io as the API group for all the code that we write. Now, I want to make this decision now rather than later, because all the code we write imports by this package name. And I wanted to get your feedback on how to proceed with this.
I would say go with storage.kas.io unless someone complains.
Okay. Now, while we're implementing, we'll be dependent on getting code into upstream now.
Right. And so the nice thing is the API groups are versioned. You have V1 Alpha 1. And so if you introduce it in V1 Alpha 1, I think API reviewers understand that this is not final. And you could potentially deprecate it without concern in the future if there was a mistake made.
Okay.
So the bar is a little bit lower.
Okay, that makes sense. Okay. So yeah, we can go with storage.kas.io. So yeah, the latest implementation, I had changed it to object storage because I thought it might be hard to get into storage, but this is good.
Yeah, I mean, we can run it by the API reviewers. I wouldn't bring it up as a major concern unless they do. So I think from the SIG's perspective, I'm okay with storage.kdas.io.
Okay, sounds good. So now that is resolved, there's another concern that we've been dealing with, and I don't have slides for it. Just started creating them. It is deletion. When I say deletion, I mean deletion of buckets. Deletion of buckets is an interesting problem because the deletion can be a very, very long running operation, depending on how many files or how many objects the bucket has. And I'm careful in saying how many rather than how much data it has. So the way the deletion happens in, according to the S3 API or, generally with object storage providers, is all the data has to be deleted first, and then only delete bucket succeeds. A delete bucket returns an error if there's data in the bucket. And so a deletion operation will constitute listing the objects in the bucket and then calling delete on either a group of objects or one object at a time, depending on the implementation of the backend. Now, there's a problem that comes up here, which is how do we design the deadline for the gRPC call? That is, if I have a across the board deadline for an operation, say something like 30 seconds for any given operation, or say a minute for any given operation, and if we go with this understanding that if the operation doesn't succeed in a minute, we error out, and then the operation goes to the back of the queue again, and then it gets called when it comes around.
So I have a suggestion here. I mean, you're correct that some backends definitely will have a very long-running version of this because they have to do a lot of work to delete a bucket. We should acknowledge that some will be able to do this efficiently and instantaneously because they have some garbage collection mechanism that they use to actually clean it up after the fact. I think the best way to proceed is have a return code that you can return quickly if the implementation knows that it will probably take a long time. It can just say, you know what, I got the request, I'm working on it, it's not done, but don't sit around blocking on some thread. I mean, we have this with snapshots where you can take a snapshot and it'll return success, but it'll say the successful response will include a flag that says I'm still working. You need to pull me to find out when it's really done. You could either do it through a successful return code and a flag in the response, or through an error code that is just defined to mean that try again later, I'm working on it.
Okay. Okay, and the behavior should be then if you get that, try again later working on it. Should we just put the item back into the queue and then just let it try as it gets
Yeah.
an option? Yeah.
I mean, what's the alternative? Put it back at the
Every
front of the
time.
queue? You wouldn't want to put it back at the front of the queue.
Absolutely no, no. What I mean is only when the other option is we only query when something like get bucket is called.
No,
So,
I think the you have to transition into like a deleting state, and as long as it's in the deleting state, you got to periodically try to delete it. And as long as it says yes, we're still working on that, you just stay in the deleting state and remember to keep polling. Maybe with some exponential back off with some maximum time.
wait. So that's the question actually. So exponential back off or retrying is different. If you're doing that, then you're holding the thread really.
Well, it depends how the controller is structured. I mean, there are work queues with built-in exponential backoff in the work queue,
Oh, right, yeah.
and you could just requeue it with backoff
Mm-hmm.
at the work queue and let the work queue do the backing off.
Mm-hmm.
You could also have a mode where you explicitly don't try until a certain amount of time has passed if you get back a still working on a response, because if it you know if the plugin says this is going to take a while, you don't want to try again after 2 seconds and after 4 seconds and after 8 seconds. You probably just want to immediately go to some long wait before
Yeah.
asking how's it going.
Mm-hmm.
But this pushes all of the decision making about whether to block or whether to return quickly down into the plugin, and the plugin can the plugin might guess wrong. It might return, this is going to take a while, when in fact it's only going to take 5 seconds, and then it might have been better to just block.
Mm-hmm.
But I don't know. You need a heuristic, I guess, and the plugin implementer will have way more information at their level about
Mm-hmm.
what the right thing to do is.
Mm-hmm. Understood. Now, do we want to have a deadline on operations at the plugin level? In the sense, we expect every gRPC call to always finish within a minute or something like that.
Well, I don't view that as a deadline. I mean, there's a CSI has a timeout, but it's not like a requirement that everything completes within the timeout. It's just, this is how long that we'll block, and if you take longer than that, we're going to call you again later. That's how it's interpreted.
Okay, so
And
I want to
and it should probably be like, I think it's 30 seconds in CSI. Is that, does anyone know? I don't actually remember.
I forget. I think it was something like that, and then it's also configurable in the sidecars.
Yeah, I
I
mean,
think it's
ultimately, it
configurable.
shouldn't matter what, it should just be something reasonable. Like whether
yeah,
you tune it up or tune it down, you should still get correct behavior.
right.
Yeah.
Sorry, go ahead.
Well, I'm just curious, does CSI expect the drivers or plugins, as you're calling them, to be not only idempotent, but also multi-threaded?
Yes.
Yeah.
Sure.
Okay.
Yeah, the idea is you can call multiple RPCs in parallel, and if that causes problems on the plugin side, they can have locking to block out the other calls, and they can figure out how to handle locking internally if they don't want to get multiple calls in parallel.
Yeah.
We can in Cozy, we can expect drivers to be idempotent and multi-threaded.
I believe so. I mean, I don't know if we make any special statements about what if you make a re-entering call into the exact same function with the exact same parameters while another copy of that call is still blocking. Saad, maybe you would remember what we're supposed to do
There
in
was
that
something
case.
about that in the spec. I forgot which way we put it, and whether it was on the CO side to not do that, or whether we put it on the driver side to make them more robust. Read the spec.
Yeah, but in the more general case of, like you can have multiple creates happen in parallel with different parameters. That's perfectly reasonable.
Okay.
Yeah.
Yeah, it might have been something like best effort on both sides, like make sure your driver is tolerant for cases that would cause it to behave badly, and on the CO side try and behave appropriately and not call the same call on two different threads.
It looks like for S3, we should expect like our driver to be reentrant, right? Because while it's working on deletion, we may kind of ask it to delete again.
Yeah, that's the expectation. Well, the driver has to implement that here. That's the expectation in the sense that'll be completely left to the driver about how they implement. Like Ben was saying, some drivers could be very efficient at it and might have support for it in the actual provider itself.
But like in particular, you know, if there's state that's used to ensure idempotency inside the driver, you probably will need locks around that in case you get the multiple threads coming in. But like you shouldn't be holding the lock for the whole delete operation, because if it's going to take like an hour to delete everything and you hold a lock so you can't do any other work, that's also very bad. So yeah, I think the implementers just have to think about what needs to be locked and how to deal with that.
Okay, so what you're saying is we should have a mechanism where we don't have to have the mechanism. So is that something we expect from the driver in the sense, like someone else was saying, if we should be able to call the same API multiple times, or with multiple or slightly different versions of the same operation?
I mean, you got to think about it this way. So you shouldn't call the same operation multiple times on multiple threads, but like, what if you were in the middle of a create call and then the sidecar that called it just bounced and came up again, and then when it came back up, it decided the next work it needs to do is make that create call again, when the original one is still hanging on the, you know, because the socket maybe didn't go away. So the driver was still processing that create call, and then another create call comes in with the exact same parameters while you're still processing the first one, just because the sidecar, I mean, you can't avoid situations like that. So best effort is probably.
Yeah, I think in this specific case, create, we can probably just rely on underlying object storage infrastructure, because they also need to handle that situation, right? So we can just kind of rely on that. With the deletion, it's different, because as I understand, our S3 driver is going to just go through all the objects and delete them one by one or something like that. In that case, we cannot rely probably on the underlying object storage and have to have some mechanism for in our.
But like to ensure idempotency, you're going to need some kind of locking, because like you have a name that comes in and you return an ID, and that ID should always be the same. And so like for a given set of inputs, and you got to be careful about, you know, generating that ID and making sure that two different calls coming in with the same parameters at the same time couldn't generate two different IDs, and now you don't know which one is which.
Sure, yeah, we'll need to keep kind of idempotency tokens, but I think it's again like it's up to a driver to kind of to pick up the proper idempotency token to work with.
Okay,
that's right. Yeah.
Sorry, can you explain that a little bit more? So what do you mean by idempotency token? Like just have a lock that locks on the name of the bucket or UID of it, and then having
just to the extent that you're going to take the inputs and figure out if this is something you're already working on or whether it's a brand new request you've never seen before. Like you obviously need to have a lock around that kind of decision, because if you get another parallel RPC call with the exact same inputs, they're going to race. So at least until the point where you figure out which operation this request is referring to, you need a lock.
Got it. Okay, that makes sense. So yeah, that was something, and this locking mechanism has to be on our side, right? The sidecar side.
No, it's on the plugin side. I mean, yeah, you might want additional locks on the sidecar, but the plugin, in order to guarantee idempotency in the face of potential parallel RPC calls, will need at least a little locking.
That, I feel like that complicates the plugin. Whoever is writing the driver has to know this. Is there any way we can enforce this in a more programmatic way from the sidecar side?
I don't know,
do we
need
any locking for? I'm sorry, guys. Are you talking about locking for creation? I'm trying to understand like what kind of use case we are currently. talking
just
about.
for ensuring item potency in the face of like a restarting sidecar that makes two overlapping requests with the same parameters. Yeah.
Right. Correct me if I'm wrong. Like I can talk, for example, for GCS, right? In GCS, when you create bucket, actual bucket name is an item potency token. So if you try to create the same bucket with the same name, you'll probably, the backend will just properly return you some code, like error code or whatever code. So it's actually, you can rely on the backend, and it won't create you two buckets with the same name, right?
If the backend that underlies your driver is itself able to guarantee item potency, then of course you can just delegate that.
Yep. For S3, I'm not sure, like I cannot, but I'm sure like in Amazon, you can use something like as item potency token parameter. And we can use, for example, I don't know, some sort of UID to pass, and this UID will be the same, and it will be taken from based off, I don't know, like UID of any of our object bucket resource. And you can pass it every time, and it'll correspond to specific bucket, underlying bucket.
Yeah, we're going to pass it. Yeah, we definitely are going to pass that. Now the question becomes, for creation, it's pretty straightforward.
Right.
Now, in case of, say, I start deleting and then I want to cancel, is that something that we allow?
I don't think we should go that far.
No.
No. Yeah. Yeah. Never mind. We don't do any sort of update bucket right now. Okay. I think I can't find a flaw in this. I think this sounds good.
I think with the deletion, the thing that it's a good question you raised, because deletion might be implemented in different ways in different object storage providers, right? And if you know that some of the storage providers require all the objects to be deleted before the actual bucket is deleted, then we just need to architecture our gRPC API, which is going to talk to these plugins to know that if you ask to delete, sometimes the response would be like in progress or something like that, and you need just to try again later.
Oh yeah, now that I think about it, we can just have a well-defined deletion response, something like if it's in progress, and that would clear it up.
You'd have to know if the bucket has objects in it or not. It's a different command. It's a different API call to do a recursive delete versus a delete of an empty bucket.
Should that be something the sidecar should worry about? It can be transparent to the sidecar each time. In the sense that sidecar just calls delete, and the driver will know if it has objects or not. If it does, it deletes the objects first, otherwise it just deletes the bucket.
Right. I think sidecar should be like storage provider agnostic, right? It shouldn't care about what's underneath.
Right. As far as I know, none of the storage providers allow you to delete a bucket with objects in them.
Correct.
As far as I know. Yeah.
Today.
Yeah. Yeah. Okay, so this clears up a lot. So we know how we want to proceed with the design of this. Is there any other questions any of you wanted to bring up? Jeff, did you have any other?
I think I added some comments on the create bucket.
Yeah. I just read them before this meeting. I think that makes total sense. I'll quickly open it up. Kubernetes enhancements. Yeah. So the comment was already exists. Error is returned when you have this different parameters sent for the same resource.
Right. Yeah. That's how CSI returns already exists, basically.
I see.
So this way, then you get true item potency, because you basically, if you create bucket with the same set of parameters, you always get the same results, right? So if it's a new create bucket request, after it's created, you get a okay, but then you call it again, it's more like a query, then that also returns okay, not already exists, because otherwise you're returning two different error code for the same input. So already exists is returned only if you call create bucket, and then there is already a bucket there with the same name, but this is with a different set of other parameters. So it's like incompatible. Yeah, that's
right.
That's it.
Right. I see. Okay,
yeah, that's interesting. Already exists. Yeah, maybe it's not a great name. Like to me, it might be wrong. I would say maybe it's a conflict would be a better name here, because already exists. Like it has established kind of meaning that which doesn't include that. Okay, bucket exists, but it has different parameters.
Yeah, so that's what
more like conflict.
That's the gRPC error code used by CSI. That's exactly this one already. It's a little weird. Yeah, maybe conflict is actually better with something else, but that's what they use.
Doesn't conflict also have another
meaning? I don't
meaning?
know. We can check. I don't know if there's another one that is better.
Yeah. Conflict in Kubernetes generally means the resource version doesn't match when you're updating.
Yeah, that's the API. Yeah, that's also maybe could cause confusion too.
Yeah,
probably just to be consistent, just because this is throughout the CSS spec. They use the already exists for something that is already there, but with different parameters. For all the almost all the calls.
It says create already exists.
Well, this is the pure gRPC error code. But if you look at CSI spec, the meaning is not exactly the same. So if you go just look at the CSS spec, basically just says.
Yeah, basically for CSI, the idea is that every call has to be idempotent, and idempotent means that the same response should be received for the same request. So exactly what Xing is saying. So if you have an existing object, then just return success and give us the fields of that object. You know, that's it. And this error code is reserved for, for specific cases where we want to point out that we can't complete an operation because it already exists.
Got it.
But in this situation, we kind of rely on underlying storage provider to actually to tell us that this is the case, right? Because otherwise, for ourselves to recognize the situation might be really not that easy.
Yeah. You depend on the storage vendor to tell you that. The storage vendor either relies on its own backend, and if its backend implements idempotency, that'll be easy. If it doesn't, it will be difficult.
Yep. Yeah, because I can imagine that already exists. The backend will return you already exist in all the cases. If you have the same parameters and you try to create, for example, bucket again with the same parameters, or you try to create a bucket with different parameters, I think their response might be the same, already exists.
Exactly, and the driver needs to interpret that and return the correct.
Yep.
Right, yeah. I mean, things like region and zone could, well, not zone, but region could change the meaning of this. Like if I have the same bucket but in different regions, does it already exist?
I think it depends on the object storage provider. I suspect that in Amazon and AWS, you need to specify region during the bucket creation. I might be wrong again. For GCS, the names are global, so you cannot use the same name in different regions.
Got it. Oh, I thought Amazon also had a global name, but I guess
probably you're right. Yes, I think maybe you're right. I also heard that. Yes.
The key is that the names need to be global across the universe that the CSI or that the COSI driver is responsible for. Like
I see.
If you expect to be able to use different names in different regions, then somehow the region has to be encoded into the name. Otherwise, you've broken your idempotency.
Yeah.
So
yeah, the token. Yeah. Good.
AWS, the names are global, so you can't have the same name in different regions.
Got it. Is that the same with Azure as well, or just as I'm curious. That's all. I think we have our answer already. Nope, nobody knows. Okay, we can figure it out. Okay, that's it from my side today. I wanted to go over these questions that were on our minds. I think we cleared up for the most part. Again, I would humbly request again that you take some time to review the KEP and leave your feedback. I'm going to paste the link to this on our chat here. Oh, I'm just looking at the chat message from Nicholas. Oh, error in progress. That sounds good actually. For the deletion, he suggested that the standard error code could be E in progress. It almost sounds like. So is that a HTTP response code? Is that a standard HTTP response code?
It's not a gRPC response code, which is what matters, I think.
Mm-hmm.
Yeah, oh, in the CSS spec, it uses this aborted. Its name is a little weird, but that's like in progress. Yeah, like the aborted. If you search the CSS spec, that is used when it is in progress.
Yeah. Or transaction. Well, it's not an abort really. It's a timeout almost.
I think we could be more explicit here instead of relying on error codes to give us the right behavior. Return a okay, but have a field in the response that lets you know whether the operation is still pending and requires polling to confirm or it has been completed.
Okay. Yeah. So a standard polling mechanism for every API then?
Just for deletion is what I was thinking, since that's the long running one. Everything else should just block until it's complete. And if timeout, then it's idempotent.
I would avoid that for anything that we don't expect to be long running.
Yep.
Just for the sake of complexity or?
Yep.
Okay.
Yeah, because it puts a burden on the CO side to have to deal with that every time you use it.
Got it.
It's an interesting point. Like something like create snapshot is not sync blocking, right? And having like create bucket blocking
create snapshot
operation
is blocking actually. It is blocking. Let's just well, you create until the snapshot is cut, but then you call it again. So it's blocking until the snapshot is cut, and then you can still driver can still in the backend. You can still do uploading.
Like,
it can do uploading.
Like when it returns to. Sorry, please go ahead.
I'm saying, so we are actually calling create snapshot multiple times. So create snapshot is also like a get snapshot actually. So basically it's supposed to block until snapshot is cut. And then there's the second step, which is upload for, some cloud providers, right? And then in that case, basically you just call controller, snapshot controller will call it again to call create snapshot until it is ready when this upload is finished.
That's exactly what I mean. Like it's like, you call create snapshot, but create snapshot can tell you, okay, kind of I'm not done yet, right? I'm working on it, right? So okay, I will call you later then, right? That's the situation.
It's a little different.
So it doesn't block until the snapshot is cut and uploaded, right?
Yeah, it's like one call actually. There are 2 steps inside that one call for some cloud providers. Yes. Yeah, that's true.
Yeah, basically it comes down to, we look at it on an operation by operation basis. If we believe that it's going to take a long time to complete, create snapshot was an example of that. And then delete bucket is an example of that. Then we will follow this model. Otherwise, we just do blocking.
But is this like a 2-step as well? This delete bucket? Is that like you have like several steps you can return in the middle, or what? How do you decide when to?
I think it's up to the driver to decide what it wants to do. It can make it 1-step or 2-step. If it's going to complete fairly quickly, it can complete it in 1 step and say, block, and then return a success code and say, I'm done. Everything is successful. Or if it knows there's a long running operation, it can convert itself into a 2-step process by returning immediately and saying, hey, I've started this thing, but it's not complete. Please follow up and verify that I've completed. This will be a long running process. And then it is up to the caller for the sidecars to continuously pull and get that status until it's finally deleted.
So there is a subtle difference, which is that the create snapshot is actually trying to communicate that two different things have occurred.
Yes.
And
right.
And in the delete snapshot, only one thing ever occurs. It's just a question of how long it's going to take.
Yep. Yeah. So from that perspective, it is slightly different. Completely agreed. But I think we can follow a very similar model.
Yeah.
Sounds good. All right, that's it from my side. If you have any questions, we can address them now. If not, we can end this early today, and I will look forward to your feedback on the CAP.
All right, thank you. Take care.
Yep.
Thank you.
Thanks.
Thank you.
Bye.
Thank you. Bye.